Understanding web development. Web development refers to the process of building and maintaining websites or web applications. It encompasses a variety of tasks, including web design, web content development, client-side scripting, server-side scripting, and network security configuration. Overview of frontend and backend development. Frontend development. Frontend development involves everything that users interact with directly in a web application or website. It focuses on the user interface UI and user experience UX, ensuring that the website or application is visually appealing, easy to use, and responsive across different devices and screen sizes. Frontend developers typically work with HTML, CSS, and JavaScript to create interactive and dynamic web pages. Backend development. Backend development involves everything that happens behind the scenes of a web application or website. It deals with server-side logic, databases, authentication, and server management. Backend developers are responsible for handling data, processing requests from the client side, and ensuring that the application's functionality works smoothly. Common backend technologies include server-side scripting languages like Node.js, Python, Ruby, and databases like MySQL, PostgreSQL, and MongoDB. Introduction to client-server architecture. Client-server model. Client-server architecture is a computing model in which client devices such as computers, smartphones, or tablets communicate with server systems over a network. In this model, the client sends requests to the server, and the server processes those requests and sends back responses. This architecture enables the distribution of workload and resources, allowing for efficient data processing and management. Components of client-server architecture. Client. The client is the user-facing part of the application, responsible for sending requests to the server and displaying responses to the user. It can be a web browser, mobile app, or any other software that interacts with the server. Server. The server is the backend component that receives requests from clients, processes them, and sends back responses. It hosts the application logic, databases, and other resources needed to fulfill client requests. Communication protocol. Communication between clients and servers is typically done using protocols such as HTTP Hypertext Transfer Protocol or HTTPS. HTTP secure for web applications. These protocols define the rules and standards for data exchange over the network. Importance of web technologies in modern applications. Web technologies enabling innovation. Web technologies play a crucial role in driving innovation and shaping the digital landscape. They empower businesses and individuals to create powerful, scalable, and interactive web applications that meet the evolving needs of users. From e-commerce platforms and social media networks to cloud-based productivity tools and streaming services, web technologies power a wide range of applications across various industries. Accessibility and reach. Web technologies offer unparalleled accessibility and reach, allowing users to access applications and content from anywhere with an internet connection. This accessibility enables businesses to reach a global audience and provides users with the flexibility to engage with applications on different devices and platforms. Integration and interoperability. Web technologies enable seamless integration and interoperability between different systems and services. They facilitate communication between disparate components, enabling the exchange of data and functionality across various platforms and devices. This interoperability fosters collaboration, efficiency, and innovation in the digital ecosystem. Scalability and performance. Web technologies provide scalability and performance capabilities that enable applications to handle large volumes of traffic and deliver responsive user experiences. Through techniques such as caching, load balancing, and content delivery networks (CDNs), web developers can optimize performance and ensure that applications remain responsive under heavy loads. In summary, understanding web development involves grasping the concepts of front-end and back-end development, familiarizing oneself with client-server architecture, and recognizing the importance of web technologies in driving innovation, accessibility, integration, and scalability in modern applications. Setting up your development environment. Setting up your development environment is the first step in getting started with web development. This involves configuring the necessary tools and software to create, edit, and manage your code effectively. Installing text editors and IDEs. Text editors. Text editors are lightweight software applications designed for editing plain text files. They are commonly used by web developers for writing code in languages like HTML, CSS, JavaScript, and more. Popular text editors include Visual Studio Code, Sublime Text, Atom, and Notepad++. Integrated Development Environments, IDEs. IDEs are comprehensive software suites that provide advanced features for coding, debugging, and project management. They typically include features such as syntax highlighting, code completion, debugging tools, and version control integration. Examples of popular IDEs for web development include Visual Studio, WebStorm, and PHP Storm. Setting up version control with Git. Git is a distributed version control system used for tracking changes in files and coordinating work among multiple developers. It allows developers to collaborate on projects, track changes over time, and revert to previous versions if necessary. Git is widely used in the software development industry and is essential for managing codebases effectively. Installing Git. To install Git, you can download the official Git installer from the Git website https://git-scm.com/downloads and follow the installation instructions for your operating system. Configuring Git. After installing Git, you need to configure it with your name and email address, which will be used to identify your commits. You can do this by running the following commands in your terminal or command prompt. Git config, global username your name. Git config, global user email your .email at example.com. Configuring Node.js and npm. Node.js. Node.js is a JavaScript runtime environment that allows developers to run JavaScript code outside of a web browser. It uses the V8 JavaScript engine from Google Chrome to execute code on the server side, enabling the development of server-side applications and APIs using JavaScript. Node.js also comes with npm, Node Package Manager, which is a package manager for installing and managing JavaScript packages. Installing Node.js. To install Node.js, you can download the installer from the official Node.js website https://nodejs.org and follow the installation instructions for your operating system. Node.js includes npm, so you don't need to install it separately. Verifying installation. After installing Node.js, you can verify the installation by opening a terminal or command prompt and running the following commands. Node version, npm version. These commands should display the versions of Node.js and npm installed on your system, confirming that the installation was successful. Setting up your development environment with the right tools and software is essential for a smooth and productive web development experience. By installing text editors and IDEs, configuring version control with Git, and setting up Node.js and npm, you'll be well equipped to start building and managing your web projects effectively. Introduction to HTML. HTML Hypertext Markup Language is the standard markup language used to create and design documents on the World Wide Web. It provides the structure and content of web pages by defining the various elements and their relationships within a document. What is HTML? HTML is a markup language that consists of a set of tags and attributes used to define the structure and content of web pages. It allows developers to create text-based documents that include elements such as headings, paragraphs, lists, links, images, and more. HTML documents are interpreted by web browsers, which render them into visual web pages that users can view and interact with. Structure of an HTML document. An HTML document is composed of several key components that define its structure and content. These components include document type declaration. Doctype specifies the HTML version being used and helps browsers understand how to interpret the document. HTML element, the root element of an HTML document. which contains all other elements. It is typically denoted by HTML tags. Head element contains metadata and other information about the document, such as the title, character encoding, and links to external resources. It is enclosed within head tags. Title element specifies the title of the document, which is displayed in the browser's title bar or tab. It is placed within title tags inside the head element. Body element contains the main content of the document, including text, images, links, and other elements. It is enclosed within body tags. Here's an example of a basic HTML document structure. Exclamation point dot type HTML. HTML head title my first HTML document. Title head body h1 hello world h1 p. This is a paragraph of text. P. imgsrc equals image jpg alt equals image. A ref equals https://www.example.com. Visit example website. A. Body. HTML. Basic HTML tags and elements. HTML consists of a variety of tags and elements that define different types of content and provide structure to a web page. Some of the basic HTML tags and elements include heading tags, h1, h2, h3, etc., used to define headings and subheadings within a document, with h1 being the highest level heading and h6 being the lowest level heading. Paragraph tag p, used to define paragraphs of text within a document. Image tag img, used to insert images into a web page, with attributes such as src source for specifying the image file path and alternative text for providing a text description of the image. Anchor tag are used to create hyperlinks to other web pages or resources, with the ref hypertext reference attribute specifying the destination URL. These are just a few examples of basic HTML tags and elements. HTML provides many more tags and attributes for defining different types of content and incorporating various features into web pages. Understanding HTML fundamentals, including its syntax, structure, and basic elements, is essential for anyone learning web development as it forms the foundation upon which web pages are built and designed. HTML5 Semantics and Accessibility. HTML5 introduced new semantic elements that provide more meaningful structure to web documents, making them more accessible to both humans and machines. Additionally, HTML5 provides features and attributes to enhance accessibility for users with disabilities. Semantic HTML elements. Semantic HTML elements are tags that carry meaning about the content they enclose, making it easier for search engines, screen readers, and other assistive technologies to interpret the content. Some common semantic elements introduced in HTML5 include header, defines a header for a section or a document. Nav, defines a navigation menu. Main, defines the main content of a document. Article, defines an independent piece of content. Section, defines a section of content. Aside, defines content that is related to the surrounding content but is considered separate. Footer, defines a footer for a section or a document. Using semantic elements improves the structure and readability of HTML documents, which benefits both developers and users. Improving accessibility with ARIA roles and attributes. ARIA are accessible rich internet applications is a set of attributes that can be added to HTML elements to improve accessibility for users with disabilities. ARIA roles and attributes provide additional context and information about the purpose and behavior of elements, making web content more understandable and navigable. Some common ARIA roles and attributes include: role attribute specifies the role or function of an element, such as role equals navigation for navigation menus or role equals button for interactive buttons. ARIA label attribute provides a descriptive label for an element, which can be read by screen readers to convey its purpose. ARIA descriptb attribute associates an element with another element that provides additional descriptive text or instructions. ARIA hidden attribute indicates whether an element should be hidden from assistive technologies. By using ARIA roles and attributes appropriately, developers can ensure that web content is accessible to users with disabilities, including those who rely on screen readers or other assistive technologies. HTML validation tools. HTML validation tools are software tools or online services that analyze HTML documents for syntax errors, accessibility issues, and compliance with HTML standards. These tools help developers identify and fix errors in their HTML code, ensuring that web pages are well formed and accessible. Some popular HTML validation tools include W3C Markup Validation Service, a free online tool provided by the World Wide Web Consortium. W3C for validating HTML documents against HTML standards. Web Accessibility Evaluation Tool Wave, an online accessibility evaluation tool that identifies accessibility issues in web content, including HTML documents. Axe DevTools, a browser extension for Chrome and Firefox that provides accessibility testing and debugging tools directly within the browser's developer tools. Using HTML validation tools as part of the development process helps ensure that web pages are compliant with HTML standards and accessible to all users, regardless of their abilities or disabilities. Introduction to CSS. CSS Cascading Style Sheets is a style sheet language used to describe the presentation of a document written in HTML. It controls the visual appearance of web pages by defining styles for various HTML elements, such as fonts, colors, layouts, and spacing. What is CSS? CSS is used to define the visual presentation of web pages, including aspects such as layout, colors, fonts, and spacing. It allows developers to separate the content of a web page from its presentation, making it easier to maintain and update the design of a website. CSS styles are applied to HTML elements using selectors, properties, and values. CSS syntax and selectors. CSS syntax. CSS consists of a set of rules that specify how HTML elements should be styled. Each CSS rule consists of a selector, followed by a block of one or more declarations enclosed in curly braces. Each declaration consists of a property and a value, separated by a colon. Example: selector, property, value. CSS selectors. CSS selectors are patterns used to select and style HTML elements based on various criteria. Some common CSS selectors include: element selector selects elements based on their tag name, such as P for paragraphs or H1 for headings. Class selector selects elements based on their class attribute, using the syntax .class name. id selector selects a single element based on its unique id attribute, using the syntax id name. Descendant selector selects elements that are descendants of a specific parent element, using the syntax parent descendant. Applying styles to HTML elements. Inline styles. Inline styles are CSS styles applied directly to individual HTML elements using the style attribute. Inline styles override any external or internal styles defined elsewhere. Example: P style equals color, red, font size, 16px. This is a paragraph with inline styles. P. Internal styles. Internal styles are CSS styles defined within the style element in the head section of an HTML document. Internal styles apply to the entire document and override external styles but are overridden by inline styles. Example: head, style, p-color, blue, font size, 18px, style, head. External styles. External styles are CSS styles defined in separate CSS files and linked to an HTML document using the link element in the head section. External styles can be shared across multiple HTML pages and provide a more efficient way to manage styles. Example: head, link rel equals stylesheet ref equals styles CSS, head. CSS plays a crucial role in web development by allowing developers to control the visual presentation of web pages and create engaging and visually appealing user experiences. Understanding CSS syntax, selectors, and applying styles to HTML elements are fundamental concepts for building modern web applications. CSS layouts and flexbox. CSS layouts are essential for defining the structure and arrangement of elements on a web page. Flexbox and CSS Grid are two powerful layout systems in CSS that allow developers to create flexible and responsive layouts. Box model and layout properties. Box model. The box model is a fundamental concept in CSS that defines the layout and spacing properties of elements. It consists of four main components. Content, the actual content of the element, such as text or images. Padding, the space between the content and the element's border. Border, the border around the element's padding. Margin, the space between the element's border and adjacent elements. Layout properties. CSS provides several layout properties that control the arrangement and positioning of elements within a document. Some common layout properties include display, specifies the type of box used for an element, such as block, inline, inline block, or none. Position, defines the positioning scheme of an element, including static, relative, absolute, and fixed. Float, specifies whether an element should be floated to the left or right, allowing other elements to wrap around it. Clear, determines how an element should behave in relation to floated elements, such as clear, left, clear, right, or clear, both. Flexbox for responsive design. Flexbox. Flexbox is a layout model in CSS that provides a more efficient way to distribute space and align elements within a container. It allows developers to create flexible and responsive layouts without relying heavily on floats or positioning. Key concepts of Flexbox. Flex container, the parent element containing flex items. Flex items, the child elements within a flex container. Main axis, the primary axis along which flex items are laid out. Cross-axis, the perpendicular axis to the main axis. Flex direction, determines the main axis direction. Row reverse, column reverse. Justify content, aligns flex items along the main axis. Align items, aligns flex items along the cross-axis. Flex wrap, specifies whether flex items should wrap onto multiple lines. CSS grids for advanced layouts. CSS grid. CSS Grid is a two-dimensional layout system in CSS that allows developers to create complex grid-based layouts with ease. It provides precise control over the placement and sizing of elements within a grid container. Key concepts of CSS Grid. Grid container, the parent element containing grid items. Grid items, the child elements within a grid container. Grid lines, the horizontal and vertical lines that define the grid cells. Grid tracks, the rows and columns between grid lines. Grid template areas, defines named grid areas within the grid layout. Grid template rows columns, specifies the size of rows and columns in the grid layout. Grid gap, defines the spacing between grid items and grid tracks. Flexbox and CSS Grid are powerful layout systems that offer different approaches to creating responsive and flexible layouts in CSS. By mastering these layout techniques, developers can create modern and visually appealing web designs that adapt to various screen sizes and devices. Introduction to JavaScript. JavaScript is a versatile programming language commonly used for creating interactive and dynamic web content. It runs on the client side within web browsers, enabling developers to manipulate HTML and CSS, handle user interactions, and create dynamic effects. Basics of JavaScript syntax. JavaScript syntax. JavaScript syntax consists of statements and expressions that define the logic and behavior of a script. It follows a C-like syntax with semicolons, terminating statements. Example: this is a single-line comment. This is a multi-line comment used for longer explanations or documentation. Console log: hello, world. Output: hello, world. Variables, data types, and operators. Variables. Variables are containers for storing data values. In JavaScript, variables can be declared using the var, let, or const keywords. They can hold various data types, including numbers, strings, booleans, objects, arrays, and functions. Data types. JavaScript has several primitive data types, including number, represents numeric values. For example, 10, 3.14, String represents textual data, enclosed in single or double quotes. For example, hello world. Boolean represents logical values, true or false. Undefined represents a variable that has been declared but not assigned a value. Null represents the absence of a value. Symbol represents unique identifiers. Bigint represents integers of arbitrary length. Operators. JavaScript supports various operators for performing operations on data values. These include arithmetic operators plus, comma comparison operators equals 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 logical operators and assignment operators equals plus equals 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 and more. Control flow and functions. Control flow statements are used to control the flow of execution in JavaScript programs. These include if, else statements for conditional execution, for and while loops for repetitive tasks, switch statements for multi-way branching, and break and continue statements for altering loop behavior. Functions. Functions are reusable blocks of code that perform a specific task. They allow developers to encapsulate logic, promote code reusability, and improve code organization. Functions can be declared using the function keyword and can optionally accept parameters and return values. Example: function declaration, function greet, name, return hello, plus name plus, function call, console log, greet, world, output, hello, world. JavaScript functions can also be defined using arrow function syntax, equals, introduced in ES6, which provides a more concise syntax for defining anonymous functions. JavaScript is a powerful and versatile programming language that serves as the foundation for building interactive and dynamic web applications. Understanding its syntax, data types, operators, control flow, and functions is essential for web developers looking to create engaging user experiences on the web. DOM manipulation with JavaScript. DOM document object model manipulation is a crucial aspect of JavaScript programming, enabling developers to interact with HTML elements dynamically. Through DOM manipulation, developers can access, modify, and update the content, structure, and style of web pages in response to user actions and events. Accessing and modifying DOM elements. Accessing DOM elements. JavaScript provides various methods for accessing DOM elements, including document getElementById, returns the element with the specified id attribute. Document querySelector, returns the first element that matches a specified CSS selector. Document querySelectorAll, returns a node list containing all elements that match a specified CSS selector. Modifying DOM elements. Once DOM elements are accessed, developers can modify their properties, attributes, and content using JavaScript. Common methods for modifying DOM elements include element text content, sets or returns the text content of an element. Element inner HTML, sets or returns the HTML content of an element. Element set attribute, sets the value of an attribute on the specified element. Element style property, sets or returns the value of a CSS property for an element. Event handling in JavaScript. Event handling. Events are actions or occurrences that happen in the browser, such as mouse clicks, keyboard inputs, or page load. JavaScript allows developers to handle these events and define custom behaviors in response to them. Event handling process. Event registration. Attach event listeners to DOM elements using methods like addEventListener, or by assigning event handler attributes directly in HTML. Event detection. The browser detects the occurrence of an event, such as a mouse click or key press. Event handling. The associated event handler function is executed, performing the defined actions or behaviors. Example: event registration const button equals document getElementById, my button, button addEventListener, click, function, event handling console log, button clicked. Dynamic content generation. Dynamic content generation. Dynamic content generation refers to the process of creating or updating DOM elements dynamically based on user interactions. Data retrieval. or other programmatic logic. This allows developers to build interactive and responsive web applications that adapt to user input and changing data. Techniques for dynamic content generation. Creating elements. Use methods like document create element to create new DOM elements dynamically. Appending elements. Use methods like append child or insert adjacent to add newly created elements to the DOM. Updating content. Modify the content of existing elements using properties like text content or inner event-based rendering. Use event listeners to trigger content generation or updates in response to user interactions. Example: creating and appending a new paragraph element. Const paragraph equals document create element. Paragraph text content equals this is a dynamically generated paragraph. Document body append child. Paragraph. DOM manipulation with JavaScript is a fundamental skill for web developers, enabling them to create dynamic and interactive web applications. By mastering techniques for accessing and modifying DOM elements, handling events, and generating dynamic content, developers can build engaging user experiences that respond to user actions and data changes. Introduction to Node.js. Node.js is a powerful runtime environment that allows developers to run JavaScript code on the server side. It uses the V8 JavaScript engine from Google Chrome to execute JavaScript code outside of a web browser, enabling developers to build scalable and high-performance web applications, APIs, and server-side utilities using JavaScript. What is Node.js? Node.js is built on the Chrome V8 JavaScript engine and provides a runtime environment for executing JavaScript code on the server side. It allows developers to build server-side applications using JavaScript, enabling them to use a single language JavaScript for both client-side and server-side development. Key features of Node.js include asynchronous and event-driven. Node.js uses non-blocking, event-driven I/O model, which makes it lightweight and efficient, suitable for building highly scalable and real-time applications. Large ecosystem. Node.js has a rich ecosystem of open-source libraries and frameworks available via NPM, Node Package Manager, which makes it easy for developers to integrate third-party modules and tools into their applications. Cross-platform. Node.js is cross-platform, meaning it runs on various operating systems such as Windows, Mac OS, and Linux, making it suitable for building applications that can run on any platform. Setting up a Node.js environment. To set up a Node.js environment, follow these steps. Download and install Node.js. Visit the official Node.js website https://nodejs.org and download the appropriate installer for your operating system. Follow the installation instructions provided on the website to install Node.js on your system. Verify installation. After installing Node.js, open a terminal or command prompt and run the following commands to verify that Node.js and npm Node Package Manager are installed correctly. Node version, npm version. These commands should display the versions of Node.js and npm installed on your system. Create a project directory. Create a new directory for your Node.js project using the md command. md my Node.js project. Initialize a Node.js project. Navigate to the project directory and initialize a new Node.js project using the following command. cd my Node.js project. npm init. This command will generate a package.json file with default settings for your project. Working with npm packages. npm Node Package Manager is a package manager for JavaScript that comes bundled with Node.js. It allows developers to install, manage, and share reusable code packages modules with ease. Installing npm packages. To install a npm package, use the npm install command followed by the package name. npm install package name. Using installed packages. Once installed, you can use the installed packages in your Node.js application by requiring them in your code. Const package name equals require package name. Listing installed packages. You can list all installed packages in your project using the npm list command. Node.js and npm provide a powerful ecosystem for building server-side applications and utilities using JavaScript. By understanding the basics of Node.js, setting up a Node.js environment, and working with NPM packages, developers can leverage the full potential of Node.js to build scalable and efficient server-side applications. Building RESTful APIs with Express. Express is a popular web application framework for Node.js, designed for building web applications and APIs quickly and easily. It provides a robust set of features and middleware that simplify the process of creating RESTful APIs, creating routes and handling requests. Routes in Express. Routes in Express define the endpoints, URL paths and HTTP methods that clients can use to interact with the server. Each route typically consists of a URL pattern and a handler function that is executed when the route is matched. Example: const express equals require express, const app equals express. Define a route for handling GET requests to the API user's endpoint app GET, API users, res equals handler function to respond with a list of users res.json, users, handling requests. Express provides methods for handling various HTTP methods get, post, put, delete, etc. using the corresponding functions get, post, put, delete. Middleware functions in Express. Middleware in Express. Middleware functions in Express are functions that have access to the request rec and response res objects, and the next middleware function in the application's request response cycle. Middleware functions can perform tasks such as logging, authentication, data parsing, and error handling. Example: middleware function to log request information, app use, res, next equals, console log, request, $, rec method, $, rec URL, next. Call the next middleware function in the stack. Built-in middleware. Express provides several built-in middleware functions for common tasks such as serving static files Express static, parsing incoming request bodies Express.json, and Express URL encoded, and handling cookies Express cookie parser. Error handling and validation. Error handling in Express. Express provides a special error handling middleware function that is invoked when an error occurs during request processing. Error handling middleware functions take 4 arguments, res, next, and are registered using the app use method. Example: error handling middleware function, app use, res, next equals, console error, stack, res status, 500 send, internal server error, validation. Input validation is essential for ensuring that the data received from clients is valid and safe. Express does not provide built-in validation features, but developers can use third-party validation libraries such as Express Validator to validate request data. Example: const body validation result equals require Express Validator app post API users validate request body fields body username ilnt min 5 body email isamail res equals check for validation errors const errors equals validation result if errors is empty, return res status, 400 JSON, errors array, process valid request res JSON, message, user created successfully. Building RESTful APIs with Express involves defining routes, handling requests, using middleware functions for tasks such as logging and data parsing, and implementing error handling and validation mechanisms. By mastering these concepts, developers can create robust and scalable APIs for their web applications. Introduction to React. React is a popular JavaScript library for building user interfaces, particularly for single-page applications and dynamic web applications. It provides a component-based architecture that allows developers to create reusable and composable UI components, making it easier to build complex UIs with ease. Understanding React components. React components. Components are the building blocks of React applications. They encapsulate UI elements and behavior into reusable, self-contained units, making it easy to develop and maintain large-scale applications. React components can be either functional components or class components. Functional components. Functional components are JavaScript functions that accept props input data as arguments and return React elements UI elements describing what should be rendered on the screen. Example: const welcome equals props equals return h1 hello props name h1. Class components. Class components are ES6 classes that extend the React component class. They have a render method that returns React elements and can also manage local state and lifecycle methods. Example: class welcome extends React component render return h1 hello. This props name h1. JSX syntax and component rendering. JSX syntax. JSX. JavaScript XML is a syntax extension for JavaScript that allows developers to write HTML-like code within JavaScript. JSX is not a separate templating language but a syntax sugar that makes it easier to write and visualize UI components in React. Example: const element equals h1 hello world h1. Component rendering. To render a React component into the DOM, use the React DOM render method, passing the component and the target DOM element as arguments. Example: const element equals welcome name equals John semicolon React DOM render element. Document get element by id root state and props in React. State in React. State is a built-in feature in React that represents the mutable data of a component. It allows components to manage and update their own data over time. State is typically used for storing component-specific data that may change during the component's life cycle. Example: class counter extends React component constructor props super props. This state equals count 0 render return div p count. This state count p button on click equals this set stat count. This state count +1 increment button div props in React. Props, short for properties, are inputs that are passed to React components from their parent components. They are immutable and are used to pass data from parent components to child components. Example: const welcome equals props equals return h1 hello props name h1. React DOM render welcome name equals John, document get element by id root. Understanding React components, JSX syntax, and concepts such as state and props is essential for building React applications. By creating reusable components, managing component state, and passing data through props, developers can create dynamic and interactive user interfaces with React. Building React applications. Building React applications involves creating reusable components, managing component state and lifecycle, and handling user interactions effectively. React provides a robust set of features and tools to simplify the process of building interactive and dynamic web applications. Creating React components. Functional components. Functional components are JavaScript functions that accept props as arguments and return React elements. They are used for presenting UI elements and are preferred for simple components that don't need state or lifecycle methods. Example: const welcome equals props equals return h1 hello props name h1. Class components. Class components are JavaScript classes that extend React component. They have a render method that returns React elements and can also manage component state and lifecycle methods. Example: class counter extends React component render return div p count. This props count p button on click equals this props an increment button div comma. Managing state and lifecycle methods. State management. State in React components represents mutable data that can change over time. It is typically initialized in the constructor and updated using the setStat method. Stateful components manage their own state internally. Example: class counter extends React component constructor props super props. This state equals count 0. Handle increment equals this setStat count. This state count +1 render return div p count. This state count p button on click equals this handle increment button div. Lifecycle methods. React components have lifecycle methods that allow developers to hook into different stages of a component's lifecycle, such as mounting, updating, and unmounting. Lifecycle methods include component did mount, component did update, and component will unmount. Example: class timer extends React component, constructor, props, super, props, this state equals, seconds, 0, component did mount, this time read equals set interval, equals, this set stat, seconds, this state seconds plus 1, 1000, component will unmount, clear interval, this time read, render, return div, p, seconds, this state seconds, p, div, handling user input and form submission, handling user input. React provides event handling mechanisms for capturing user interactions such as clicks, changes, and submissions. Event handlers are typically defined as methods within class components and are invoked in response to user actions. Example: class TextInput extends React component, constructor, props, super, props, this state equals, value, handler change equals event equals, this set stat, value, event target value, render, return input type equals text value equals, this state value, on change equals, this handler change, comma, handling form submission. React allows developers to handle form submissions using event handlers such as onSubmit. Form data can be retrieved from form elements and processed as needed, such as submitting data to a server or updating component state. Example: class login form extends React component, handler submit equals event prevent default, const form data equals new form data, event target, process form data, render, return form on submit equals, this handler submit, input type equals text name equals username semicolon, input type equals password name equals password semicolon, button type equals submit, login, button, form. Building React applications involves creating reusable components, managing component state and lifecycle, and handling user interactions effectively. By understanding these concepts and best practices, developers can build robust and interactive web applications with React. React hooks. React hooks are functions that enable functional components to use state, lifecycle methods, and other React features without writing a class component. Hooks provide a more concise and readable way to manage component state and side effects, making it easier to write and maintain React code. Introduction to hooks. What are hooks? Hooks are functions that allow functional components to use React features such as state and lifecycle methods. They were introduced in React 16.8 as a way to write reusable and composable logic within functional components. Why use hooks? Simplified code. Hooks eliminate the need for class components and provide a more concise syntax for managing state and side effects. Reusability. Hooks can be reused across multiple components, promoting code reuse and reducing duplication. Improved readability. Hooks make it easier to understand and reason about the behavior of functional components. UseStat, UseEffect, and custom hooks. UseStat hook. The UseStat hook allows functional components to add stateful behavior. It returns a state variable and a function to update that variable, and it can be called multiple times within a component to manage multiple pieces of state. Example: import React, UseStat from React, const counter equals const count, set count equals UseStat 0, return div p count p, button on click equals set count plus 1, increment, button, div. UseEffect hook. The UseEffect hook enables functional components to perform side effects, such as fetching data from an API, subscribing to events, or updating the DOM, in response to component lifecycle events. Example: import React, UseStat, UseEffect from React, const timer equals const seconds, set seconds, equals UseStat, 0, UseEffect, equals, const interval equals set interval, equals, set seconds, seconds plus 1, 1000, return, equals, clear interval, seconds, return p, seconds, p. Custom hooks. Custom hooks are functions that encapsulate reusable logic and stateful behavior in React components. They allow developers to extract complex logic from components into separate functions, promoting code reuse and separation of concerns. Example: import useStat, useEffect from React. Const useTimer const seconds, set seconds, useStat, 0, useEffect, const interval set interval, set seconds, seconds plus 1, 1000, return, clear interval, seconds, return seconds, export default useTimer, context API for state management, context API. The context API is a feature in React that allows data to be passed through the component tree without having to pass props manually at every level. It provides a way to share state between components without using props drilling. Example: import React, create a context, use a context, use a stat from React. Create a context for the theme const theme context create a context. Create a provider component to provide the theme to child components const theme provider children const theme set theme useStat light return theme context provider value theme set theme children theme context provider. Create a custom hook to access the theme context const user theme return user context theme context usage const app const theme set theme user theme return div button on click set theme light dark light toggle theme button div export default app. React hooks provide a powerful way to manage state, perform side effects, and share logic between components in functional components. By understanding useStat, useEffect, custom hooks, and the context API, developers can build more concise, readable, and maintainable React applications. React Router. React Router is a popular routing library for React applications that enables client-side routing, allowing developers to create single-page applications with multiple views or pages. It provides a declarative way to define routes and handle navigation within a React application. Client-side routing with React Router. Installation. To use React Router in a React project, you need to install the React Router DOM package using npm or yarn. npm install React Router DOM. Basic usage. React Router provides components such as browser router, route, and link to define routes and handle navigation. The browser router component wraps the entire application and provides the routing functionality. Example: import browser router, route, linked from React Router DOM. Const app return, browser router, div, nav, li, link to home, link, link to about, link, link to contact, link, nav, root path exact component home, root path about component about, root path contact component contact, div, browser router, nested routes and route parameters, nested routes. React Router allows you to define nested routes by nesting route components within each other. Nested routes are useful for organizing and structuring complex applications with multiple levels of navigation. Example: const app return, browser router, div, nav, link to products, link, link to services, link, nav, root path products component products, root path services component services, div, browser router, const products return div, h2, products, root path product side, component product detail, div, root parameters. Root parameters allow you to capture dynamic segments of the URL and pass them as props to the rendered component. Root parameters are denoted by a colon, followed by the parameter name in the root path. Example: const product detail equals match equals return h3 product id match params id h3 protected routes and redirects. Protected routes are routes that require authentication or authorization before rendering the component. React Router provides a redirect component to handle redirects to a specified location when the user is not authenticated. Example: const privateroute equals component rest equals return route rest render equals props equals isauthenticated component props comma redirect to equals login comma semicolon redirects. The redirect component in React Router allows you to redirect users to a different location within the application. It is typically used in response to user actions or as part of authentication and authorization logic. Example: import redirect from React Router DOM. Const logout button equals const handle logout equals perform logout logic return redirect to equals login semicolon return button on click equals handle logout button. React Router is a powerful library for handling client-side routing in React applications. By understanding its basic usage, nested routes, route parameters, protected routes, and redirects, developers can create dynamic and navigable single-page applications with ease. Introduction to databases. Databases are an essential component of modern applications, providing a structured way to store, manage, and retrieve data. There are different types of databases, including relational databases and NoSQL databases, each suited for different use cases and requirements. Relational versus NoSQL databases. Relational databases. Relational databases organize data into tables with rows and columns, following a predefined schema. They use SQL, structured query language, for querying and manipulating data. Relational databases are suitable for applications with complex data relationships and transactions. Example relational databases: PostgreSQL, MySQL, Oracle Database, Microsoft SQL Server. NoSQL databases. NoSQL databases are non-relational databases that store data in flexible, schema-less formats, such as key-value pairs, documents, or graphs. They are designed for scalability, high availability, and performance, making them suitable for handling large volumes of unstructured or semi-structured data. Example NoSQL databases: MongoDB, document-based; Redis, key-value store; Cassandra, wide column store; Neo4j, graph database. Overview of PostgreSQL. PostgreSQL is a powerful open-source relational database management system RDBMS known for its reliability, robust feature set, and extensibility. It supports SQL standards and features advanced capabilities such as transactions, foreign keys, triggers, and stored procedures. Key features of PostgreSQL. ACID compliance. PostgreSQL ensures data integrity and consistency by supporting ACID, atomicity, consistency, isolation, durability transactions. Extensibility. PostgreSQL allows developers to extend its functionality using custom functions, data types, and procedural languages. Replication and high availability. PostgreSQL supports various replication methods for creating standby servers and achieving high availability. Full text search. PostgreSQL provides built-in support for full text search, making it suitable for applications with search requirements. Installing and setting up PostgreSQL. Installation. PostgreSQL can be installed on various operating systems, including Linux, Mac OS, and Windows. The installation process may vary depending on the operating system, but generally involves downloading the installer from the PostgreSQL website and following the installation instructions provided. Setting up. Once installed, PostgreSQL needs to be initialized and configured before use. This typically involves initializing the database cluster, starting the PostgreSQL service, and creating a database and user for application access. Example commands: initialize the database cluster init the path to data directory. Start the PostgreSQL service pgctl path to data directory start. Create a new database and user created my database create user. Interactive. PostgreSQL provides a comprehensive set of features for storing and managing relational data. By understanding the differences between relational and NoSQL databases, the features of PostgreSQL, and the installation and setup process, developers can leverage PostgreSQL effectively in their applications. Working with PostgreSQL. PostgreSQL is a powerful relational database management system (RDBMS) that supports a wide range of SQL, structured query language features for querying, inserting, updating, and deleting data. Additionally, PostgreSQL provides advanced capabilities for database schema management, indexing, and optimization. SQL basics, queries, inserts, updates, deletes, querying data. SQL queries are used to retrieve data from PostgreSQL tables based on specified criteria. The select statement is commonly used for querying data, along with clauses such as where, order by, group by, and join. Example: select all records from the users table. Select from users. Select users with age greater than 30. Select from users where age 30. Select users and their corresponding orders. Select uname. O order id from users U inner join orders O on U user id equals O user id. Inserting data. The insert statement is used to add new records to PostgreSQL tables. It allows developers to specify values for the columns being inserted. Example: insert a new user into the users table. Insert into user's name. Age values John Doe, 35. Updating data. The update statement is used to modify existing records in PostgreSQL tables. It allows developers to update specific columns based on specified conditions. Example: update the age of the user with id1. Update users set age equals 40 where user id equals 1. Deleting data. The delete statement is used to remove records from PostgreSQL tables based on specified conditions. Example: delete users with age less than 18. Delete from users where age 18. Creating and managing database schemas. Creating tables. Tables in PostgreSQL are created using the create table statement. Developers can specify the table name, column names, data types, constraints, and other properties. Example: create table users user id serial primary key, name vacha, 100, age int. Managing constraints. PostgreSQL supports various constraints such as primary keys, foreign keys, unique constraints, and check constraints for ensuring data integrity and consistency. Example: add a foreign key constraint, alter table orders, add constraint fk user id foreign key user id references users, user id. Creating indexes. Indexes in PostgreSQL are used to improve query performance by providing faster access to data. Developers can create indexes on specific columns to speed up search and retrieval operations. Example: create an index on the email column in the users table. Create index IDX email on user's email. Indexing and optimization techniques. Understanding query execution plans. PostgreSQL provides the explain statement to analyze the execution plan of SQL queries. Understanding query execution plans helps developers optimize queries for better performance. Example: explain select from users where age 30. Indexing strategies. PostgreSQL supports various indexing strategies such as B-tree indexes, hash indexes, and gist indexes. Choosing the right indexing strategy depends on factors such as query patterns, data distribution, and performance requirements. Example: create a B-tree index on the age column in the users table. Create index IDX age on user's age. Query optimization techniques. Developers can optimize SQL queries by using techniques such as query rewriting, query tuning, denormalization, and caching to improve performance and efficiency. Example: rewrite a subquery as a join to improve performance. Select uname. O order id from users U inner join orders O on U user id equals O user id. Working with PostgreSQL involves mastering SQL basics, creating and managing database schemas, and employing indexing and optimization techniques to ensure optimal performance. By understanding these concepts, developers can build efficient and scalable applications with PostgreSQL. Introduction to Web3 and Blockchain. Web3 and blockchain technologies have revolutionized various industries, including finance, supply chain management, and decentralized applications dApps. Understanding blockchain technology and tools like Web3.js is crucial for developing decentralized applications and interacting with blockchain networks such as Ethereum. Understanding blockchain technology. What is blockchain? Blockchain is a distributed ledger technology that enables peer-to-peer transactions without the need for intermediaries. It consists of a chain of blocks, where each block contains a time-stamped list of transactions cryptographically linked to the previous block, forming an immutable record of transactions. Key features of blockchain. Decentralization. Blockchain networks operate without a central authority, relying on a distributed network of nodes to validate and record transactions. Transparency. Transactions recorded on the blockchain are transparent and accessible to all participants, promoting trust and accountability. Immutability. Once recorded, transactions on the blockchain cannot be altered or deleted, ensuring data integrity and security. Consensus mechanisms. Blockchain networks use consensus mechanisms such as proof of work or proof of stake, POS, to achieve agreement among network participants on the validity of transactions. Overview of Web3.js library. What is Web3.js? Web3.js is a JavaScript library that provides an interface for interacting with Ethereum-based blockchain networks. It allows developers to build decentralized applications dApps and interact with smart contracts deployed on the Ethereum blockchain. Key features of Web3.js. Blockchain interaction. Web3.js enables developers to connect to Ethereum nodes and interact with the blockchain, including reading data, sending transactions, and deploying smart contracts. Smart contract interaction. Web3.js provides APIs for deploying, invoking, and interacting with smart contracts written in Solidity, Ethereum's smart contract programming language. Event handling. Web3.js supports event handling, allowing developers to listen for and react to events emitted by smart contracts. Interacting with Ethereum blockchain. Connecting to Ethereum node. To interact with the Ethereum blockchain using Web3.js, developers need to connect to an Ethereum node, either running locally or on a remote server. Ethereum nodes expose JSON RPC endpoints that Web3.js can communicate with. Example code. Const Web3 equals require Web3. Connect to a local Ethereum node. Const Web3 equals new Web3. http://localhost:8545. Check connection status Web3 ethnet ice listening. Then console log.catch. Console error. Reading data from blockchain. Web3.js provides APIs for reading data from the Ethereum blockchain, such as account balances, transaction details, and smart contract state. Example code. Get balance of an Ethereum account Web3 ETH get balance 0x1,23,456. Then console log.catch. Console error. Sending transactions. Web3.js allows developers to send transactions to the Ethereum blockchain, including transferring Ether between accounts and invoking methods on smart contracts. Example code. Send Ether to another Ethereum account Web3 ETH send transaction from 0x1,23,456 to 0 zapdef value Web3 utils TAUI 1 Ether. Then console log.catch. Console error. Understanding blockchain technology and tools like Web3.js is essential for building decentralized applications and interacting with blockchain networks. By mastering these concepts, developers can leverage the power of blockchain to create innovative and secure applications. Building decentralized applications dApps. Decentralized applications dApps leverage blockchain technology to create trustless, transparent, and secure applications without the need for intermediaries. Building dApps involves understanding smart contracts, integrating Web3.js with front-end frameworks like React, and deploying applications on blockchain networks such as Ethereum. Smart contracts and Solidity basics. What are smart contracts? Smart contracts are self-executing contracts with the terms of the agreement written in code. They run on blockchain networks and automatically execute transactions when predefined conditions are met. Smart contracts are typically written in programming languages like Solidity. Solidity Basics. Solidity is a high-level programming language used for writing smart contracts on Ethereum and other blockchain platforms. It is statically typed and supports inheritance, libraries, and complex data types. Example smart contract. Simple smart contract to store and retrieve a value pragma solidity 0.8.0. Contract simple storage. 256 public store function set. 256x public store equals x. Function get. Public view returns 256. Return store. Integrating Web3.js with React applications. Web3.js integration. To interact with Ethereum blockchain networks in React applications, developers can integrate Web3.js using NPM or Yarn. Web3.js provides APIs for connecting to Ethereum nodes, reading blockchain data, sending transactions, and interacting with smart contracts. Example integration. Import Web3 from Web3. Connect to an Ethereum node const Web3 equals new Web3. http://localhost:8545. Example usage. Get accounts Web3 get accounts. Then console log.catch. Console error. Handling Ethereum accounts. Web3.js allows developers to manage Ethereum accounts, including generating new accounts, importing existing accounts, and signing transactions with account private keys. Example. Generate a new Ethereum account const new account equals Web3 eth accounts create. Import an existing Ethereum account const imported account equals Web3 eth accounts private kit account. 0 zapdef. Deploying dApps on Ethereum testnets. What are Ethereum testnets? Ethereum testnets are alternative Ethereum blockchain networks used for testing and development purposes. They mimic the behavior of the main Ethereum network but use test ether. For example, Rinkeby, Robston that has no real-world value. Deploying dApps. To deploy dApps on Ethereum testnets, developers need to compile smart contracts using Solidity compilers, deploy contracts to testnet nodes using tools like Truffle or Remix, and interact with deployed contracts using Web3.js in front-end applications. Example deployment with Truffle. Compile smart contracts Truffle compile. Deploy contracts to testnet. For example, Rinkeby, Truffle migrate, network Rinkeby. Deploying dApps on Ethereum testnets allows developers to test their applications in a real-world environment without risking real funds. It also enables users to interact with dApps and provide feedback before deployment to the main Ethereum network. Building decentralized applications involves mastering smart contracts, integrating Web3.js with front-end frameworks like React, and deploying applications on blockchain networks. By understanding these concepts, developers can create innovative and secure dApps that leverage the power of blockchain technology. Integration of frontend and backend. Integrating frontend and backend components is essential for building full-stack applications that provide a seamless user experience and efficient data flow between the client and server. This integration involves implementing authentication and authorization mechanisms, managing sessions and cookies, and developing communication protocols between front-end and backend layers. Building full-stack applications. What are full-stack applications? Full-stack applications encompass both front-end, client-side and backend, server-side, components, allowing developers to create end-to-end solutions that handle user interactions, data processing, and storage. Key components. Front-end, the user interface of the application, typically built using HTML, CSS, and JavaScript frameworks like React, Angular, or Vue.js. Backend, the server-side logic of the application, responsible for processing requests, executing business logic, and interacting with databases or external APIs. It can be built using languages like Node.js, Python, Java, or Ruby. Authentication and authorization. Authentication. Authentication is the process of verifying the identity of users accessing the application. It typically involves username password authentication, social login OAuth, or token-based authentication mechanisms. Authorization. Authorization determines the permissions and privileges granted to authenticated users. It restricts access to certain resources or functionalities based on user roles or permissions. Example flow. User logs in using credentials. Backend verifies credentials and generates an authentication token. Token is sent to the client and stored, for example, in local storage or cookies. Subsequent requests include the token for authentication and authorization. Session management and cookies. Session management. Session management is the process of maintaining user sessions on the server side, allowing users to remain authenticated across multiple requests. Sessions are typically stored on the server and associated with a unique session identifier, session ID. Cookies. Cookies are small pieces of data stored in the client's browser, often used for session management, user preferences, or tracking. They are sent with each HTTP request to the server and can be accessed and manipulated by both the client and server. Example flow. Server creates a session for the authenticated user and stores session data. Server sends a session ID to the client via a cookie. Client includes the session ID in subsequent requests. Server retrieves session data based on the session ID and performs authentication and authorization checks. Implementation in full-stack applications. Frontend integration. Implement login and registration forms. Store authentication tokens securely. For example, using local storage or HTTP-only cookies. Include token in request headers for API calls. Backend integration. Verify credentials during login authentication. Generate and validate authentication tokens. For example, JWT. Restrict access to protected endpoints based on user roles permissions. Session management. Implement session handling middleware in the backend. Store session data securely. For example, in memory, database, or distributed cache. Set appropriate session expiration times and invalidate sessions upon logout or inactivity. Cookies. Set cookies with appropriate attributes. For example, HTTP only, secure, SAMAZIT. Include session ID or authentication token in cookies for subsequent requests. Integrating frontend and backend components involves implementing authentication and authorization mechanisms, managing sessions and cookies, and ensuring secure communication between client and server layers. By understanding these concepts and best practices, developers can build robust full-stack applications that provide a secure and seamless user experience. Real-world projects and case studies. Real-world projects and case studies provide valuable insights into applying theoretical knowledge to practical scenarios. Here are 3 examples of real-world projects and case studies. 1. E-commerce platform with payment integration. Project overview. Develop an e-commerce platform that allows users to browse products, add them to the cart, and proceed to checkout. Implement payment integration to accept payments from customers securely. Include features such as user authentication, product search, and order management. Technologies used. Frontend, HTML, CSS, JavaScript, React.js. Backend, Node.js, Express.js. Database, MongoDB or PostgreSQL. Payment integration, Stripe, PayPal, or other payment gateways. Case study. Analyze existing e-commerce platforms like Amazon, eBay, or Shopify to understand user experience and functionality requirements. Implement secure authentication mechanisms to protect user data and transactions. Use SSL/TLS encryption for secure communication between the client and server. Implement a responsive design to ensure the platform is accessible on various devices. 2. Social media application with user interaction. Project overview. Create a social media platform where users can create profiles, connect with friends, and share posts, photos, and video. Implement features such as newsfeed, notifications, likes, comments, and messaging. Ensure scalability and performance to handle a large number of users and interactions. Technologies used. Frontend, HTML, CSS, JavaScript, React.js. Backend, Node.js, Express.js. Database, MongoDB or PostgreSQL. Real-time communication, WebSockets, Socket.io. Case study. Study popular social media platforms like Facebook, Twitter, or Instagram to understand user engagement features and design patterns. Implement real-time updates using WebSockets to notify users about new posts, comments, or messages. Use authentication and authorization mechanisms to control access to user data and interactions. Implement algorithms for newsfeed customization based on user interests and activities. 3. Cryptocurrency exchange platform. Project overview. Build a cryptocurrency exchange platform where users can buy, sell, and trade digital assets securely. Implement features such as order book management, trading charts, and wallet integration. Ensure compliance with regulatory requirements and security best practices. Technologies used. Frontend, HTML, CSS, JavaScript, React.js. Backend, Node.js, Express.js. Database, PostgreSQL or MySQL. Cryptocurrency integration, APIs. For example, Coinbase, Binance. Case study. Study existing cryptocurrency exchanges like Coinbase, Binance, or Kraken to understand trading mechanics and user interface design. Implement secure authentication and authorization mechanisms to protect user accounts and transactions. Integrate with third-party APIs to access real-time market data, execute trades, and manage user wallets securely. Implement order matching algorithms and trade execution logic to ensure fair and efficient trading. Real-world projects and case studies provide practical learning experiences and opportunities to apply theoretical knowledge to solve real-world problems. By working on projects like e-commerce platforms, social media applications, and cryptocurrency exchanges, developers can gain valuable skills and insights into building scalable, secure, and user-friendly applications. Deployment and scaling. Deployment and scaling are crucial aspects of building robust and resilient applications that can handle high traffic and provide reliable services to users. This involves deploying applications on cloud platforms, scaling them to accommodate increasing loads, and implementing continuous integration and deployment, CI/CD, pipelines for efficient development and deployment workflows. Deploying applications on cloud platforms. Cloud platforms. Cloud platforms like Amazon Web Services AWS, Microsoft Azure, Google Cloud Platform GCP, and Heroku provide scalable infrastructure and services for deploying and running applications in the cloud. Deployment methods. Manual deployment. Manually upload application files to cloud servers and configure infrastructure components. Automated deployment. Use deployment tools like Oz Elastic Beanstalk, Heroku, or Docker containers to automate the deployment process. Example deployment. Oz Elastic Beanstalk. Create an application and environment on Oz Elastic Beanstalk. Upload application code or container images to Elastic Beanstalk. Configure environment settings such as instance types, scaling options, and environment variables. Deploy the application to the Elastic Beanstalk environment. Scaling applications for high traffic. Vertical scaling versus horizontal scaling. Vertical scaling. Increase the capacity of individual server instances by adding more resources CPU, RAM, storage. Horizontal scaling. Add more server instances to distribute the workload across multiple nodes. Load balancing. Use load balancers. For example, Oz Elastic Load Balancer, proxy to distribute incoming traffic across multiple server instances and prevent overload on individual servers. Auto scaling. Implement auto scaling policies to automatically adjust the number of server instances based on predefined metrics such as CPU utilization, request latency, or incoming traffic. Continuous integration and deployment. CI/CD pipelines. CI/CD pipelines. CI/CD pipelines automate the process of building, testing, and deploying applications, enabling developers to deliver changes to production quickly and reliably. Key components. Version control. Use version control systems like Git to manage application code and track changes. Continuous integration. CI. Automatically build and test application code whenever changes are pushed to the repository. Continuous deployment. CD. Automatically deploy tested changes to production or staging environments. Example CI/CD workflow, GitHub Actions. Developer pushes code changes to the GitHub repository. GitHub Actions triggers a build and test job for the application. If tests pass, GitHub Actions deploys the application to the production environment. Best practices. Monitor application performance and infrastructure health using monitoring tools like Oz CloudWatch, Datadog, or Prometheus. Implement logging and error tracking to diagnose and troubleshoot issues quickly. Use infrastructure as code IaaC. Tools like Terraform or Oz CloudFormation to manage and provision cloud resources. Implement security best practices such as encryption, network segmentation, and access control to protect sensitive data and resources. Deploying and scaling applications on cloud platforms. Implementing CI/CD pipelines and adopting best practices for monitoring and security are essential for building reliable and scalable applications that can handle high traffic and deliver a seamless user experience. By leveraging cloud services and automation tools, developers can streamline the development and deployment process and focus on delivering value to users.